Assalamu alaikum and a very warm welcome to everyone. Now we're going to be looking into design pad, which is given by GEDP number D1 on soil compaction. Okay. As always, please fill in the details accordingly. Let's look at the first problem. So this scope is on laboratory compaction tests, ASTM D698 and D1557. Number 1, specification. The combined weight of a mold and the specimen of compacted soil contains 4000 G. The mold's volume is 944 centimeter cube. The mold's weight is 2023 gram. The specimen's water content is 10%. And what is required? A, wet unit weight of the specimen, and B, dry unit weight of specimen. And let's look at the solution. For A, wet unit weight of specimen, just use the following equation. Please replace it accordingly, and then the wet unit weight of specimen would be calculated as 20.9 kilonewton per meter cube, because everything is given in the specification. And let's look at B. We have to find the dry unit weight of specimen. Similar approach but different equation. So from equation D1, you can calculate the dry unit weight of specimen. Just replace all the parameters accordingly, and you will calculate your dry unit weight of specimen as 19 kilonewton per meter cube. Let's move on to problem number 2, specification. Still under the scope of laboratory compaction tests. A set of laboratory compaction test data and result is tabulated as follows. The test was conducted in accordance to ASTM D698 standard proctor test. So the first data, second, third, fourth, and so on. And what is required? Plot a proctor curve, dry unit weight versus moisture content, and B, determine the soil's maximum dry unit weight and optimum moisture content. Let's look at the solution. So you're going to plot something like this. Okay. So you have your dry unit weight on the y-axis and moisture content on the x-axis. And these are your data points from the table. So make sure everything is well defined in this graph. Now let's move on to B. Determine the soil's maximum dry unit weight and optimum moisture content. Pretty easy. From figure above, the maximum dry unit weight is 18.7 kilonewton per meter cube, and the optimum moisture content is 12.5%. Let's look at problem number 3. This is in-place soil unit weight test. Specification. During construction of a soil embankment, a sand cone in-place unit weight test was performed in the field. The following data were obtained. Weight of sand used to fill the test hole and funnel of sand cone device is 867 gram. A, weight of sand to fill funnel is 319 gram. Unit weight of sand is given as 1.5 gram per centimeter cube. Weight of wet soil from the test hole is 747 gram. Moisture content of soil from test hole as determined by speedy moisture meter is about 13.7%. So you can see this is two parts here. So these are the Ottawa sand, A and B, and C and D is from the soil from site. What is required? Dry unit weight of the compacted soil. Remember, you have sand and you have soil. Now solution. So the weight of sand used in test hole is calculated as weight of sand to fill test hole and funnel minus weight of sand to fill funnel. So 867 gram minus off with 319 gram, so we're left with 548 gram. Volume of test hole, use the weight of sand over the unit weight of sand, and you get volume of test hole as 356 centimeter cube. So let's go back to the soil. So wet unit weight of soil in place is equals to 747 gram, which is the C, divide by 356 centimeter cube, the volume. So you'll get the wet unit weight of soil in place about 21 kilonewton per meter cube. And lastly, from equation D1, you'll be able to calculate the dry unit weight of compacted soil. You have the unit weight, wet unit weight of soil. You also have 0.137, which is your, what is 0.137 here? It's in percent. Oh, speedy moisture meter. Okay, your moisture content from the soil. So in the end, you can calculate your dry unit weight of compacted soil as 1.84 kilonewton per meter cube. It's pretty easy. Let's look at problem number 4. Specification given as, so this is field control of compaction. So soil from borrow pit to be used for construction of an embankment gave the following laboratory results when subjected to a standard Proctor test. Okay. So maximum dry unit weight is 18.6 kilonewton per meter cube. Optimum moisture content is about 12.5%. The contractor during construction of the soil embankment achieved the following. Dry unit weight reached by field compaction about 18.5 kilonewton per meter cube. And actual water content is 13.7%. And what is required? Percent of compaction achieved by the contractor. Solution. So the percent of standard Proctor compaction achieved is in place dry unit weight over the maximum laboratory dry unit weight multiplied by 100. So you get roughly about 98.9% of compaction achievement from the contractor. Let's look at problem number 5. Still in the scope of field control of compaction. Specification. A borrowed pit soil is being used as earth fill at a construction project. The in-situ dry unit weight of the borrowed pit soil was determined to be 17.18 kilonewton per meter cube. The soil at the construction site is to be compared to a dry unit weight of 18.90 kilonewton per meter cube. The construction project requires 15,000 meter cube of compacted soil fill. And what is required? Volume of soil required to be excavated from the borrowed pit to provide the necessary volume of compacted fill. And the solution given as follows. Firstly, you have to calculate the total dry weight required to furnish the compacted fill, which is equals to total dry weight of soil required to be excavated from the borrowed pit. So 18.90 kilonewton per meter cube multiplied by 15,000 meter cube. So you get roughly about 286,500 kilonewton. Okay. And volume of soil required to be obtained from the borrowed pit is, so we just divide by the dry unit weight of the borrowed pit, 17.18 kilonewton per meter cube. And in the end, you get the volume of soil required is 16,500 meter cube. So take note that this is dry weight in kilonewton and volume in meter cube. Okay. Now let's look at problem number 6. So this is still on field control of compaction. The specification as follows. The in situ void ratio of a Burroughs pit stall is 0.72. The Burroughs pit stall is to be excavated and transported to field at construction site where it will be compacted to a void ratio of 0.42. So from 0.72, it will be compacted to 0.42. The construction project requires 10,000 meter cube of compacted soil fill. And the required volume of soil that must be excavated from the Burroughs pit to provide the required volume of fill. And the solution. So you're going to make 4 equations here by using simple maths equation. So firstly, subscribe F as the soil in the field from the equation of void ratio. So make sure you have F here. So represent a soil in the field. So 0.2 multiplied with the remaining parameters in that equation will give you equation A. And the volume equation, the total volume is 10,000 meter cube. This will be your equation B. So you make a simple substitution and you'll get your volume as 7,042 meter cube. Okay, so that's one part. And you're going to have to subscribe another B as soil in the Burroughs pit. So the same approach, but just label it B. Okay, so it will be your equation C. So from basic equation, okay, you will be giving derivation for equation D, and then you make some arrangement, and in the end the thing that you want to calculate is total volume of soil from Burroughs pit, which is roughly about 12,112 meter cube. Okay, so take note of all of this. It's just a simple maths in order to get the volume. Okay, that's all about it for the design pad on soil compaction. Thank you very much.